Now for our last long talk, or our first long talk and the last long talk, we are going to hand it over to Stefano Puliti, who is going to talk to us about open science for 3D forest vision.
Hello, thanks Alex for having me here. Yes, so again, feeling like a fish out of water in a community of people looking at a lot about animals. I will talk about trees. So I'm Stefano and I work in Norway at NIBIO in the National Forest Inventory Department. And the work I'll present here is largely part of collaboration that I have with my colleagues Rasmus, Binbin, and Maciej, which is our dream AI forest team. And it's about 3D trees and 3D forests. And how do we get there? We shoot lasers at trees and we record their coordinates of all of these laser pulses, and that's how we get these beautiful representations of trees. And this work is largely funded by Smart Forest, which is funded by the Norwegian Research Council. And so what we do is basically we want to see the forest for the trees. I know that many will not like that, but actually that's what we really want to do and what has been our challenge for about 5 years. And so we collect all this LiDAR data over forests, and as you see, they look beautiful. We see all these trees. The trees, however, they don't have these beautiful colors in the raw data that we get. They are just points in space. So what we want to do is that we want to, first of all, segment each of these trees so that we can start to talk to each of these trees and interrogate them about what they represent in this forest. And then once we know about the individuals, we can then say something about the community. So once we segment the trees, then we want to extract biometrics for these trees. And these include species, include height, ground volume, it includes the health of the species of the tree, the age, the growth, and many aspects that are relevant for ensuring a better management of the forest, both for conservation purposes or for productive purposes, or in general, multi-purpose use of forests. So this is our overarching goal that we've been aiming at for the past 5 years. But let's dive a little bit in where this started, where our open science effort started. And that was about during COVID, so about 5 years ago. And I had wrote a paper. I thought it was fantastic at the time, and then submitted it to a journal, and then this was the answer. Big fat rejection, which of course in the beginning you think, oh, this is very unfair, this doesn't make any sense. And then going through actually the revision, the main criticism was that we had a very small site with few trees, and our findings would not be really transferable beyond our site. And taking that in and digesting that, I started to think a little bit, how can we address this? And then another negative thing came, COVID. So then we were all stuck in our offices, and then all that massive globalized world became very small. And then I felt this urge to really connect with some of the greater community that was out there. So then I started sending paper airplanes around the world, and then hoping that there would be people around the world that would be able to share these data so that finally that paper could be accepted in a way that and that it would address those comments from those reviewers. So actually turned out that many of those paper airplanes did come back, and that was a fantastic understanding for me of the fantastic community that actually was out there, and people were really eager to share data. Unfortunately, many were eager to share data that was useless, so was a lot of work also on kind of thresholding and finding what was the data that we needed and how do we do that. So that took a lot of time. So it's very easy to send out emails and get emails back, but actually to start working and compiling this data, it's very time consuming, something that took me about 5 years to learn. And then we started compiling these data sets. While the first one was this, we called it the 4-instance data set. So we called the overall family of data sets. They are the 4 family. And the first one is the 4-instance, which is a collection of point clouds, forest point clouds, where each tree it's individually segmented, and then different parts of the tree are also segmented. So it's useful for both instance and panoptic segmentation. And it comprises about 1,000 trees from different biomes and from different also type of management. And the data was published in an archive paper, and it's available on Zenodo. And the second data set, which I guess is what connects me a little bit to why I was invited here, it's a recently published paper in Methods in Ecology and Evolution, where we compiled this data set of individual trees with associated tree species. And our goal was to benchmark individual tree species classification. So in this case, we managed to collect 20,000 trees covering about 33 species, mostly around Europe, but also from other continents. And also from different sensors and different platforms. We wanted to remain fairly agnostic in regard to what data one can throw at the models that can be developed using this data set. And also these are available on Zenodo. So what we did after compiling the data sets is that we started developing methods. So we took these data sets, and then what we wanted to do initially, the first challenge that we had, and there was a long-standing challenge for about 20 years, no one really knew how to accurately segment individual trees. So we developed 2 state-of-the-art deep learning models for instance segmentation of forest point clouds. And that took a lot of effort, but finally we did start to obtain fairly good results. And we are still in the process of making these better and more applicable. Now we're looking at corner cases like tropical forests and stuff that you think that would be totally unreasonable to segment. And then in regards to species, this is what we did in the paper that I mentioned before. We actually we had a data science competition, and we benchmarked all kind of the main methods that had been proposed until today. So basically, we converged in 5 months. We were able to converge on the most suitable methods to classify tree species, starting from these point clouds. A work that hadn't been achieved in 5 years of research before by iterations on separate data sets. So very important to have this kind of common benchmark data sets attached with no kind of strings attached. And then, so that was what we had initially intended to develop the data sets for. And then suddenly new ideas came, and then people started using our data sets for new things. So suddenly now we are using this 4-species data set for generative AI, generative point cloud AI. So basically we want to create a virtual forest that doesn't exist, but that has certain characteristics that can be used for simulations. So then we can take all of these trees and generate new ones based on this library of trees that we developed. Another possible use that we are looking into is also for developing allometric models. So foresters are obsessed with this diameter at breast height, which is the one measure that we were able to get until now, before all this laser scanning came about. So it remains still important. So for example, if we want to predict diameter, but based on the crown of the tree, so then this is one of the ways that we can also use these data sets. So to conclude, I would like to just have a little reflection on the importance of open science nowadays. And I think Henry already pointed at it. I think it's crucial that we focus on open science, and especially PhDs and the new generation of researchers that are coming out. Because science as we know it, as this public good that it's open to everyone, that creates knowledge that it's available to everyone. it's actually being challenged, where we have like these big corporations, big tech, that is where the big advances in AI are being made. It's really challenging and competing with the purpose of public good science. So there are basically these techno-political borders that are rising, and it's more and more challenging to collaborate beyond these borders. So I think that scientists have really a role nowadays to take these walls down and to actually create communities that go well beyond these borders. So in addition to those simple challenges that we have nowadays, like climate change and biodiversity loss, those are easy to solve, right? But we also have these geopolitical challenges that we also have to address, and we cannot look away anymore, right? So I think it's really important that the new generation looks at these things in a serious way, and that looks at how we build together something that is useful for the public good. Because regardless of this fair principle, and unfortunately, like these big companies like Fair, Meta, right? They start to use this name, OpenAI, and these names, they start to really be damaged by this big tech. Uh, Meta, yes, they publish a lot of their models, but they publish none of their data. So their reproducibility of the methods is just not there. So it's up to us to really make this available to everyone and usable by everyone. And regarding to the question of how does one commercialize this data, I think that it's a question that will get solved by itself. Once you are open, things come back to you. So don't worry about being open, and just share what you have with no strings attached, and link to your colleagues. And to conclude, I would like to introduce this new EU project that we started and I'm coordinating, which is called Single Tree, and we'll be of these things in more detail. We'll be developing a lot of more advanced point cloud and 3D computer vision. So tune in and follow those channels if you are interested in forest and 3D stuff. Thank you very much.
Thank you so much. That was so incredible. And I'm loving this like common theme through some of these presentations about community engagement and power of community, because that's obviously what we're all about here. And I think that ties in really nicely to open source solutions and funding and finance group call out that Henry mentioned during the ad break. One question I have is, I know that you mentioned that most of those data sets are from North America and Europe. Are there what can people do, / is there any interest, / are there any plans to get more data from other continents in the global south, / I guess what can people do to get that data over to you guys to build out a more well-rounded set?
Yeah, so we're always very open, and we're all continuously working on updating these data sets. Now we're working on the 4 species 100K. The challenge is a little bit the accessibility to these kind of scanners, right? That is not super cheap. It is becoming a lot cheaper. So there will be definitely developments in the future. So anyone that is willing to collaborate is very welcome to get in touch with us, and we're very happy to include anyone in co-authorship. And really, like, I think it's not so much about that. It's really about creating communities and things that are long-standing.
Amazing. Well, thank you so much again. If anybody else has any questions, you feel free to pop them in the chat, and I will direct you over there to answer them. And actually, no, we have one question that just came in, and we have a few minutes to answer it before we pass things over to Steph. Simone, do you want to ask your question, or we can ask it for you?
So is this is the manual segmentation of the point clouds also a challenge to get the data? Yeah, so basically that used to be a bit of a challenge, but now we can run basically those segmentation models that we developed before also on non-segmented free or non-segmented point clouds. So we accept also point clouds that are not segmented, and we will soon have some data calls out. So keep your ears open or your eyes open. Will be stuff popping up on social medias.
Nice. Oh, we have a follow-up question. Do the segmentation models work with non-European data?
Yes, yes. We train them not just with European data. The reason why we have mostly European data is that honestly, we haven't been so successful in getting data out of the US, mainly because that's where most of the other data has been collected, but there is a bit more restrictive policy access to the data, for what I understand in the US. So, and whenever I hear like people that want to sign contracts and so on, then for me it all falls apart, right? Like either it's without strings, or if it gets complicated, then it becomes really not an effort that is worthwhile, because it's already a massive effort to compile this data.
For sure. Yeah. Well, thank you so much. I'm looking forward to seeing what else comes out of that with the 10,000. I forgot what the full title was, but 10,000 is a crazy number. And that is super exciting. Congratulations again. And thank you for coming and talking.